Okay, so let's talk about what's next, and that's these weird looking graphs. So these graphs have a little something going on with them. All right, so this tells you to use cosine and to use sine for this. Now you could go the other way, and if you went the other way, you'd have you'd have more shifting. Okay, honestly, you just have more shifting, and I'm going to I'm going to accept doing the less shifting. So let's get to what I mean. Let me grab my note. Little plan. Okay, so if we say that we're using cosine for this graph, right? You can see that the midline has moved. The midline is usually here, but that's not where the midline is. The midline now is here. So that means something moved upward. All right. So that's something to put in the back of your head. So if this is the midline, what is the amplitude? It's 2. 1, 2. From the midline to the lowest point is 2, or from the midline to the highest point is 2. So amplitude is 2. Second, the period. If I go up, then 0, then down, then 0, then up again, that is a complete cycle. So what's the distance for the complete cycle? 6 pi. So that's what I got. I got 2 pi divided by the frequency equals 6 pi. So then what's the frequency? It's not 1. That's close. It's 1/3. 2 pi divided by 1/3 is 2 pi times 3 over 1. That's 6 pi. So the frequency is 1/3. Now, why did I tell you to do that? Well, we'll get to that in a second. So we know the period is 6 pi. One complete cycle from 0 to whatever, that's 6 pi. That's the distance it takes to make one complete cycle. Phase shift. Phase shift is left or right. Well, the thing didn't move from left to right. So none or NA. The vertical shift, though, it's supposed to start right here. That's where this graph is supposed to start. Right here. Well, it moved up how many? 1, 2, oops, my fault. Nah. If this is the midline, it moved up 1, 2, 3. It moved up 3. Yeah, that's interesting. Why is that up there when it should be right there? Say it again, sir. Because if I look at the graph, it cuts it in half. That's I mean, mid means middle. I mean, just think about it. It just cuts the graph in half. Every time we've looked at a sine or cosine graph, that's been the middle. You know, and if I cut this, that's the top half, that's the bottom half. All right. So the distance from the midline to the lowest point or midline to the highest point, that's 2. And then we go 1, 2, 3. So the thing moved up 3. I swear it looks like it moved up 4 though. That's interesting. Vertical shift is 3. Yep. Okay, so now we need to make the function. So the function is y equals, now we said we wanted a cosine graph. So we put the amplitude, so that's 2 cosine. The frequency is what? 1/3 x. And that's my function. Oh, my fault. Sorry. Yep. You know what? I owe you a piece of candy. +3. Yep. You definitely have to put +3. Yep. I would have got a point marked off. All right. So, what do we do about the second one? Say it again, sir. All right. There isn't a vertical or a horizontal shift, but what's the amplitude? Amplitude is 1/2. From the midline to the highest point is -1/2, well, 1/2 or +1/2. So amplitude is 1/2. This is a sine graph. It's a Z. But wait a minute, it's a backwards Z or an upside down Z. So it's mirrored or is negative. Yep, reflection. So my graph is or my function is going to be y equals negative. So then I got the amplitude, that's 1/2. So 1/2 sine. I don't so what's my period? It's 2 pi over 5. Because even though my graph is reflected, there's the 0, low point, 0, high point, 0. So that's one cycle at 2 pi over 5. And so if it's 2 pi over 5, and I know that the period is 2 pi over the frequency, what's the frequency? It's 5. The phase shift, there's none or 0 or not available or not applicable, excuse me. And then the same for the vertical shift, none. So then that's my answer. Anybody have any questions on that? All right, well, I'm going to go over this just for the sake of argument. Before I erase this, does anybody have any questions? All right, so let's look at what we got if we did it the other way. I'm planning on Monday, but I'm not going to say Monday. I'm going to say sometime next week. All right. So if we think about sine, so let's think about sine, the weird looking Z, right? So we know sine looks like this. That's how a sine graph looks. It goes 0 up, 0 down, 0. Well, that wouldn't start till right here. You see what I'm talking about? That's when it would start. It would start right here because that's how that little backwards or whatever Z starts. So I've got to look at if this was supposed to start right here, I got to look at how much it moves to the right and how much it moves up. So everybody got what I'm saying? If I think about sine, like I said, sine graphs go like that. And that's where graph would start. So amplitude is still the same. There's the midline, 1, 2. So the amplitude is still the same. All right. Now I've got top, dot, dot, dot. Now even though we're talking sine, it's pretty much 5 points. 1, 2, 3, 4, 5. So when I got those 5 points, I know that that's a cycle. So where's my period? My period's still the same. It's 6 pi. My period is still the same. right? So then we go back to the frequency. So what's the frequency? Well, the same way I did it before. I've got 2 pi over frequency equals 6 pi. So my frequency is 1/3. Now let's look at where the phase shift and the vertical shift is. My graph is supposed to start right here. And it started right here. So phase shift is how much to the left or right it moved. So if it's here, how much to the right did it move? It moved 9 pi over 2. So the phase shift is 9 pi over 2. And then I go for the vertical shift. If this is where my graph was supposed to start, and it's technically starting right there, 1, 2, 3. And now I start setting up my graph. So I got y equals 2 for the amplitude sine 1/3 x minus 9 pi over 2 plus 3. So that's where if we use this as a sine graph, how much it would move over. So then let's look at this one. I don't think I'm going to give you one this challenging, although I do kind of want to put in phase shift or vertical shift. So I'd like to do something with that. I haven't figured out how the graph's going to look yet. So let's figure out if we were using cosine for this one. So cosine looks like a U. Well, that don't look like a U. See, here's the U right here. That's the U. So then the question would be, where would my graph technically, where was it supposed to start? Yep, where is it supposed to start? Hmm? Supposed to start at what? Okay. Sine looks like that. It's a weird looking Z. Cosine goes like that. It's like a weird U. It starts high, goes to 0, hits low, goes back to 0, then ends high. It's number 4. You can't tell what? I don't understand. Okay. First, we're going to go right here. Consider the graph. Determine the amplitude, period, phase shift, and vertical shift of each. Then write an equation for the function. Hint, 3 is a cosine graph, 4 is a sine graph. But as I was telling you earlier, the graphs can be either sine or cosine. It just means you got to do some more, your equation has to change some. So we did it as sine. We did this as a reflected weird looking Z. We did that, but I'm saying it's possible to do this as not a weird looking Z, but as the cosine, which is a U. So I think about that weird U, and I think about where would the U start? Well, technically, let's see, the U is starting, let's see, he's starting at the next spot over here somewhere. So it moved over, it moved way over actually. That's where it would start. Because that's the high point. Starts at the high point, hits 0, hits the low point, goes back to the high point, or it goes back to 0, then the high point. So that's where it would start. What do you mean convert it? Okay. The thing is that the graph could be either. It's not so much flip it. It's just it looks it looks like it's easier to do sine. I still wanted to prepare you for phase shift and vertical shift in a graph because if I only do this and you never had to see it, then it's like I'm not teaching it to you. So I want you to have to think about phase shift and vertical shift. So that's technically where the graph would have started if we was running a graph how it was a regular graph. So then that means it moved over that far. That's what it means. It means it moved over that far. So if it moved over that far, what's let's start putting some stuff in here. What's my amplitude? It's 1/2. It's the distance from the midline to the low point or the midline to the high point. So 1/2. Right? Now we can say that that's 5 points. So what would be my period? What would be my period? 2 pi over 5. So 2 pi over 5. So then what's my frequency? Say it again. 5. All right. So now phase shift. Phase shift means left or right. That's technically where it would have started if we're looking at cosine. So what's the phase shift? 3 pi over 10. All right. And so the vertical shift, there is none. Vertically, it stays where it is. So now let's write this down. I got y equals 1/2, because that's the amplitude, cosine. Frequency is 5. X minus 3 pi over 10. And then there's no vertical shift, so then that'd be it. So now we got a little matching. So we've got 1, 2, 3, 4, 5, 6. We got 7 equations and we got 7 graphs. We need to match them. So you got the thing in front of you. So let's start matching these graphs up. Let's look at these equations and find some graphs that match. 23 is A. So let's look at it. Sine graph. Remember, it's the weird looking Z. It starts at 0. Amplitude is 4. So right here, 2, 4. If they give you something that looks like this on a graph, that means each mark is 2. So then that mark is 4. So this graph has a height of 4. If if I'm looking at this number, what number is that? That 4 right here. The frequency. So that means that 2 pi over 4 is my period, or pi over 2. Well, if I look at this graph, goes up, that's pi over 4. Pi over 2 is right there. Now, how do I know that? Because this is supposed to be pi, that's pi over 2, and then that's pi over 4. Pi over 4 is half of pi over 2. So I can see that this little spot right here and this little spot right here are the same distance. So I know my frequency is 4. My period is pi over 2. So I'm going to have 1, 2, 3, 4 within 0 to 2 pi. I have 4 of them. And that's all the information I can glean from that. I've got 4 for the amplitude and 4 for the frequency. So yep, she is right. It's A. All right, let's pick out something else. 25 is C. So again, we need an amplitude of 4. So there's 2 4. So yep, that's 4. I'm sorry, right here. Sorry, that's 4. Right? Cosine starts at the high point, hits 0, hits the low point, goes back to 0, then ends at the high point. This graph has a halfway point. It's the same as the first one because look, y equals 4 cosine 4x, y equals sine, or if y equals 4, sine 4x. So this graph has a frequency of 4. So it has a period of pi and a half, or excuse me, half pi. And the frequency is 4. So yep, that's C. 26 is B. So 26 has, again, an amplitude of 4. Well, we can just do process elimination. That has 4, that has 4. If we use these two, the only other one that has 4 for my amplitude for 0 to the high point of 4 is 26. And then the frequency is 1/4. The frequency is 1/4. So if the frequency is 1/4, that means the period is pi over 8. No, excuse me, it's 8 pi, sorry. And if I look here, this mark is 2 pi. So then that means this mark is 4 pi, this mark is 6 pi, this mark is 8 pi. So one complete cycle is 8 pi. So we got 3 out of 7. Let's get another one. Come on, folks. Okay, so 24. We got y cosine of x plus pi. So no number in front means it's an amplitude of 1. Said D. So it's cosine. So cosine should start right here. It should start high. Well, it's not at 0. It's at pi where it started. You know what? I'll take that back. Make sure I do this right. So what ended up happening was the way this graph goes, that's actually the end. The start is somewhere over here. It went this way, pi. Because remember what I told you about that formula? It's x minus c. Well, if it's x plus c, then that means it moved to the left. So it moved pi to the left. And that's all we got for this graph. Frequency is 1, so the period is 2 pi. And the amplitude is 1. So we got 3 left. So what do we got? 28 is what? Say it again. We got E, F, and G, the last three. So let's look at, okay, so 27 is E. Sine, so the amplitude is 1, right? Well, if it was sine and the amplitude is 1, the highest spot it would be is at 1. Or that I shifted it upward. I moved it upward. And there ain't no moving it upward here. So that shouldn't be it. All right. So let's look at F. So I got sine of 2 of x plus pi over 2. So my graph is supposed to start right here. Well, they drug it, because that's plus, they drug it this way. Well, there we go again. It's actually supposed to start right here, and they drug it that way. This distance right here is pi over 2. Let's see what else we got. The frequency is 2. So that means that the cycle is pi. Right here, that's pi. Because this is 1/4, this is 2/4, this is 3/4. So what would this be? Yep, or 4/4. So pi over 4, pi over 2, 3 pi over 4, and pi, or 4 pi over 4. So yep, that's F. Say it again. Let's find out. So let's look at G and look at 28. So when I look at 28 and 29, they both got some kind of movement. But see, 28 has minus. Minus means it's moving down. So E, if it moved at all, it moved up. And G, it moved down. So, yep, without having to do a lot of figuring out, because my graph went from here down here, from here to there, 28 is G. And then by process of elimination, that's E. So its cosine is supposed to start at the high point, but it moved up 1. It was supposed to start here, and it started there. Supposed to start here, but it started there. And then the frequency is 1/2. Frequency being 1/2 means the period is pi over 4 pi. So if I look here, halfway mark is at 2 pi. The completed graph is at 4 pi. So that works out. Has anybody got any questions about this? Because I'm gonna put matching on there. Yeah, not bad. Not bad. All right, so let's knock this last little bit out and then we're done. All right, so rewrite each expression so that the term is in the form of k times x to the n power, where k is a real number, x is a positive real number, and n is a rational number. So let's look at the first one. I got the same base, so what am I doing? Got the same base and I'm multiplying. What am I doing? I'm adding my exponents. So I've got x, that's my base, to the negative 2/3 and x to the 1/3. So what's left? Negative 1/3. Now notice, they didn't say that they wanted the exponents to be positive. So you can stop right there. X to the negative 1/3. All right, what about B? Okay, so the first thing I'm going to do is I'm going to have 8 because that's 2 times 4. And then, of course, I'm going to have X. And now I got X to the 1/2 and X to the negative 5/2. So what do I get? Say it again. It's negative 4 over 2, which is 8 to the X to the negative 2. Or 8 to the, yeah, 8 times X to the negative 2 power. All right, so we'll leave C and D for you. Let's try E. So this is an old school distributive problem. I've got X times 1/2 or X to the 1/2 power times 2 times X to the square second power. Oh, excuse me. So if I multiply those, what do I end up getting? Because I'm distributing. So I'm going to have 2x to the what? What is 1/2 plus 2? When you multiply, you add your exponents. What's 1/2 plus 2? No, it's 2 and 1/2. 2 halves is not the same as 2 and 1/2. 2 halves is different. So 2.5 or 5 over 2. And then I multiply x to the 1/2 power times this negative 4 over x. If you got something like that, it might be easier to switch this around so you're dealing with something that looks like this. That's x to the 1/2 power. So I'm gonna take this and make this negative 4 times x to the negative 1 power. So now I've got x to the 1/2 power times negative 4x to the negative 1. So what do you get? You get negative 4x. Say it again. Negative 1/2 power. Yep. All right. Let's do one of these. How about we do h? H, instead of distributing and multiplying, now we're going to sort of distribute and divide. We're going to split this up. We're going to have 2x to the 4th over the square root of x minus x squared over square root of x minus 3x over the square root of x. Well, I know what the square root of x is as an exponent. It's what? Come on, somebody. What's the square root of x as a fractional exponent? You need to know it's not new. We know that fractional exponents can be converted to radicals, and radicals can be converted to fractional exponents. So, what is the square root? How can I write that as a fractional exponent? The root is the denominator. The power that you take it to is the numerator. Negative 1/2. Well, you don't have to call it negative 1/2. You can just say 2x to the 4th over x to the 1/2. Because it's in the denominator, it's not negative. Because it's in the denominator, it's not negative. It'll be negative if I move the denominator up to the numerator, which I could do, but I can just as easily do it like this. Oops, I ran out of room. So now I just deal with each of these pieces individually. When I divide with the same base, what do I do to my exponents? I subtract. So I'm going to have 2 x to the 4th divided by x to the 1/2. So that's 4 minus 1/2, which is what? Say it again. Excuse me. So that's 2 times x to the 3/2. No, not 3/2. Nope, sorry. I did the exact same thing that I was just calling y'all for. Yep. So if it's 3.5, that's 7/2. 7/2 x. Maybe I should get that right. Okay, so that's 2x to the 7/2 power. Okay, so then the next one, I've got x to the 2nd power divided by x to the 1/2 power. What do I get there? So I got x to the 3/2 power. And then I've got this one here, 3x divided by x to the 1/2. And there's my answer. Say it again. Because it's not negative. Because the top is 1, the bottom is a fraction. So it's 1 minus a half is a half. If the half was in the denominator and I was moving it to the numerator, that's when you change. All right, so I'm going to leave the rest to you, and that's it.